Let me teach metals and non-metal reaction. Sodium oxide, you must know how many elements are there. There are two. One is sodium, another one is oxygen. Sodium 11 means 281. You see one electron outside. So I write Na1 dot, electron. Oxygen is having atomic number 8. We write 26. You must see last electrons, valence electrons. Electrons present in the last orbit. Means oxygen, I write 1, 2, 3, 4, 5, 6. It gives one electron because you must see in the penultimate shell 8 electrons. Stability, octet. That is why it wants to lose. To become stability or octet configuration, it wants 2 electrons. 2 electrons. At a time, sodium cannot give 2 because only one is there, it wants 2. What happens? Another sodium comes. That is adjustment, one more electron. 281 configuration. What happens here? Electron jumps. How many Na? 2. So what we write Na twice. It is a +1. And oxygen 1, 2, 3, 4, 5, 6, 7, 8. It has accepted 2 electrons. That is why it leads to a formula called Na2O. Here, complete transfer of electrons, valence electrons. It leads to a type of bond called ionic bond. Strong electrostatic force of attraction. Between sodium and oxygen, there is a presence of strong electrostatic force of attraction. That's why more heat is required to break the bond. That is why ionic compounds have high melting point. They are rigid. Sodium chloride, rigid body, rigid structure. High MP, high melting point. Easily they are soluble in water, less in organic solvents. So they may ask the questions, why they have high MP, high BP. And remember, sodium chloride crystal cannot allow the current to pass, crystal, rigid body, no free electrons. But sodium chloride, when you put into water, it splits into ions. Then it allows the current to pass through. So that is why this is called ionic compounds. Sodium oxide, Na2O. Another example, if you want, say aluminium oxide. Aluminium oxide. There are 2 elements. One is aluminium, another one is oxygen. If you take aluminium atomic number 13, I hope 283. 3 valence electrons. It wants to donate only 3. Oxygen, if you take 8, it is having 2 and 6. It wants to donate all 3. Last. Then question comes aluminium and oxygen. 1, 2, 3. Here oxygen 1, 2, 3, and here 1, 2, 3, 4, 5, 6. It wants 2 electrons. How it is possible to give? That's why one more aluminum, 1, 2, 3. Means from this aluminum 2 electrons can be donated. It gets satisfied. Another oxygen, 1, 2, 3, 4, 5, 6. 2 here, 2 here. This oxygen is satisfied. 2 more are left. So one more oxygen. 1, 2, 3, 4, 5, 6. So 2 are donated here. 2 are donated here. And 2 are donated here. Means 2 aluminum and how many oxygen? 3. That is why what we write as Al twice. 3 are donated plus 3. Oxygen 1, 2, 3, 4, 5, 6, 7, 8. It has accepted 2, but there are 3. Hence, it leads to aluminum oxide. In the exam, you should write oxygen here. There is no space here. That's why I have written there. O, O, O. Neat, in a neat manner, you have to write. And this one has to be written after this. First, atomic numbers. Next, donation of electrons. Then, charges. Then, formula. This is the method. Usually, such questions will be asked for 2 marks. This is one more type where metals react with non-metal. These are called ionic compounds. You must go through the properties. Okay. Next, third and final version, we'll go to the next after this. Okay.